when we take a derivative, the power goes down by 1. So the power comes down and multiplies as a coefficient, and then the power gets reduced by 1. So an antiderivative would mean the power goes up by 1. So if you do negative 6/7 plus 1, you get x to the positive 1/7. Because negative 6/7 plus 1, that's negative 6/7 plus 7 over 7, right? So that's our new power, but this isn't quite the full antiderivative, because if you were to take a derivative of this term, the derivative of the antiderivative should bring you back to where you were. If you were to take a derivative, a 1/7 would come down and multiply, then the power would get reduced by 1. So the power is correct, but we have an extra coefficient out here, right? So this isn't the antiderivative yet. We just need to multiply by 7 out front. And now this is the antiderivative, because if you take a derivative of this term, it turns into this term. And then the general antiderivative, so we add some constant c, because look, if you were to say plus 1, the derivative of this expression would still be this, right? If you said plus 2, the derivative of this expression would still be this. So that's why we say plus some arbitrary constant c when we evaluate an antiderivative. Okay, so that's the general antiderivative of that term. And then to find an antiderivative of this function, it's the same type of thing. The antiderivative of that negative 6/7 we just worked out is 7 times x to the 1/7. And then this constant is still multiplying out front. Just like with a derivative, when you find an antiderivative, the constants can just stay out front and multiply. So we just need to simplify. 7 divides into 42 evenly. So that's 6. So I think we got 41 over 6 x to the 1/7. But another way of writing x to the 1/7, you could write it as a 7th root, right? This is 41 over 6, and then 7th root of x. Those are the same thing. Okay, back from usually the end of algebra 2 or the beginning of, or somewhere near the beginning of pre-calculus. X to the 1/7 is the same thing as the 7th root of x.